So the next thing we'll do is open up QGIS, and I'll show you how to import your data, do some processing, and then re-export into formats that you can import into TileMill for visualization. So QGIS, or Quantum GIS, is an open source project that's been around for over a decade, and it's basically the leading open source GIS tool which allows you to do any kind of geographic data analysis. So to download QGIS, you can go to their website and go to download now. And like all the tools I'm using, QGIS is cross-platform, so you can download it either for Windows or Mac or Linux. So once you download the software, you can open up QGIS, and you want to go to the Quantum GIS desktop. And this will load up the QGIS software, which basically looks like this. And I won't go over this software very comprehensively. In this case, I'll just go through the applications that are relevant to the type of data we're using and the type of visualizations that we want to create. Okay, so to start off with, we're going to import some data. So up here, there's a toolbar which lets you import different kinds of data. Here you see vector layers, which are shape files, raster layers, which are image files, and these are the main two types of data that you work with in GIS. However, they have their proprietary types of file names. Specifically, we're going to be using .shp files for shapefiles and .tiff files for rasters. In this case, we have our data as a table, which isn't by default a GIS file type, but it can be imported into QGIS as long as it has latitude and longitude information. So here we can click on this icon to add delimited text layers. So if we click on that, we can browse for our CSV file, and it's the same file from before. So I loaded that in. I tell it how the data is separated. In this case, it looks like it's loading it correctly, and then I have to tell it what the X and Y field is. So by default, QGIS will look for lat as the latitude field, which is the Y axis, and long as the longitude field, which is the x-axis. So in this case I use a different name, so I just have to tell it that the x-axis or longitude is in the LNG field. And now I can click OK, and here I have to specify a projection type. Now projections can be a bit tricky, and a thorough discussion of them is a bit beyond this class. So I'll just go through and show you a basic way to do projections. There's two basic kind of projection systems, and they're all listed in this interface. There's geographic coordinate systems, and there's projected coordinate systems. Geographic coordinate systems basically relate to the latitude and longitude measurements of the globe, and projected coordinate systems project that kind of global spherical data onto a flat sheet of paper. So typically geographic coordinate systems are measured in latitude, longitude. Projected coordinate systems are measured in linear measures such as meters or feet. So because our data is coming in as latitude and longitude, we have to use a geographic coordinate system when we import the data. And the one we're going to use is the most basic one, which is called WGS84. So I have it saved here. If you don't have it up here, you can just type in WGS84, and it'll come in here under geographic coordinate system. So make sure you pick this one, and it has this identification number. Okay, so this is our point data. Again, we don't have a base file under this, so it's a bit harder to see where the points are, but because we know what this data looks like, we know that here's New York City in the big cluster, and then we have some other data points. So the first thing we'll do is actually convert this point data, which right now is just a referenced CSV file, into a proprietary GIS file type, which is the shapefile. So to do that, I go here in my layer view, and I'll just go to save as, and here I can specify the type of file format I want, which I want a shapefile, and I'll browse to where I want to save it, and I'll save as a shapefile here, and I'll click OK. And it's exported our file. And now we can browse to where that file was created, and you can see that here it's created 5 different types of files. The base file is shapefile, but it also includes other file types that GIS actually uses to work with a file. So here we have a database file, which actually contains all the data in that data set, and then we have a projection file, which tells it how to project the file. So in order to bring this into QGIS, we can go to Add Vector Layer, and here we can browse to it and select it here, the .shapefile. Alternatively, we can just drag and drop from our Explorer window. Make sure you use the shapefile here and just drag it into the map. So we'll place it there. You can see because we use the same projection type, it's placed itself right on top of the map, and at this point we can just delete this original file, which was our CSV file, and here we have actual shapefile of the data. So to visualize the actual database behind these points, we can right click and go to Open Attribute Table. This will open the table, which is the same as what our CSV was, but it's very important to know that with GIS there's always 2 views to the data. There's the map view, which shows you the coordinates of all the data points and where they are in the world, and there's this database file which has this ID, which is linked to one of the points. Once we have converted to a shapefile, we can start to actually edit that shapefile to either remove points we don't want, create new points, or move the points around. So to edit in GIS, by default, none of these things are editable because GIS by default is a data viewer, not an editor. So it's a little bit different from what you might be used to with other graphic editing applications, that by default you can just navigate and visualize and use this data, but to edit it you actually have to go into what's called editing mode. So here you can click this pen to toggle editing, and now you have the possibility of editing these points. So if I go into my selection window here, I can start to select a group of points. Once they're selected, I can delete them by hitting this delete key, and it'll ask me if I want to delete them. So now I can very quickly go through and delete all the points that maybe were misplaced. Now if I really was concerned about having a full data set, I wouldn't want to delete them. I'd obviously want to figure out what went wrong and get the actual locations, but for the purposes of this demo, I'll just quickly delete them. Another thing I can do is actually select individual points, and I can move those points to new locations. So if that was a little misplaced, I can always move it. Obviously without a base map, it's a bit hard to do that. So once I'm done editing, I can hit the save button. That will save any changes that I made to my data, and then I can unclick the editing mode. So within QGIS, you have a lot of the same kind of visualization options as you do in the online tools. You can go into any of the layers. So here I have a point type layer. I can go to properties, and then I have control over the style. So this is similar to what we saw in CartoDB. We have single symbol. We can make it bigger, smaller, apply, preview it, so all the circles got bigger. We can also do categorized visualization. So here I can use the categories. I can bring in all the categories, and I can give it a starting color scheme. And here it'll basically give a different color to each dot depending on what category it's a part of. So you can do a lot of the same kinds of visualizations in QGIS as you could in the online tools, but for the purposes of what we're going to do, I suggest that if you're dealing with point data, just keep it as points and then import it and visualize it in TileMill, because that will make it really easy for you to bring in the map box. Any visualization you do with QGIS will help you visualize it here, but when you bring that shapefile into TileMill, you will lose all those visualizations anyway. Okay, so the next thing I'll do is I'll bring in a base layer of New York just so we can see where these points are a little bit better, and I'll show you how you can actually bring in other types of shapefiles into QGIS. So if I click the import vector layer, I can go navigate to my folder where I have this New York City base file saved out, and I'll open that. and you'll see it brought in all the census tracts of New York City, and we can reorder the layers here to basically put that layer underneath, and we can maybe quickly change that color to something lighter. And then we can also get rid of the stroke, or maybe just make it dashed and much lighter. Okay, so that will give us a little better idea of where our geometry is. Again, this is just an underlay in QGIS. Mapbox and has its own underlays that you can use, which are often better than the ones we have available. So this is just to visualize the maps as you're working with them.